Hi, welcome to Hayward's Maths. If there's an example you're looking for, here's the list. Check out the one you need. Hope it helps.
We've been doing normal distribution. So getting a whole bunch of data, putting it into a normal distribution. So do you remember some of the examples that I did? The real life examples? Yes. Toe size, yeah? Picking a toe size that's like 5 centimeters long or something like that. And we found out it was like 75% chance of finding that toe size. We're going back the other way today. Today we're looking for a size. So we're given a probability, so we want to find 80% of all the data in a normal distribution. What's that value, what's that toe size it goes up to, or what's that swimmer weight, or what's, any continuous random variable. What's that number we're going up to? And this is called inverse normal. If you haven't read ahead, inverse normal. So essentially, in the past, if you look at this example, we were given this and we wanted to find this. Does that make sense? Today we're doing the opposite. So today we're given this and we're trying to find that value. First of all, what does the Z stand for? Standardized normal distribution, very good. So we have a mean of what when it's standard normal distribution? 0, and the standard deviation is? Yep. Just to refresh your memory. So this is saying what value of A, so what Z-score is going to be a probability of 32% or 0.32. So where on the graph roughly is that going to be? At this point in the middle, all of this area is equal to 0.5. So the probability in that area under the curve, that's all equal to 0.5. Because it's the mean, it's in the middle. Does that make sense? And it's symmetrical. Does anyone not understand what? So we could say P, Z less than 0, which is the mean, equals 0.5. So where is the 0.32 going to be? Roughly. Is it going to be left of the mean or right of the mean? So it's going to be somewhere in here. This A value. And that's going to give us the area under the curve for a standard normal distribution of 0.32. So I've already got the answer there, but I'll show you where it is. Probability, distributions, inverse normal is what it's called. So it's inversing the normal distribution. So because it's a standard normal distribution, you leave the mean as 0 and the standard deviation as 1. And we're trying to find the area 0.32. So we're trying to find what value or what Z value it goes up to. And there you have it there. 0.32 is the area, mean 0, standard deviation 1. The Z value is negative 0.467699. So that's what that value is in there. So using inverse norm and 699. So that's a standard normal distribution. Now we're going to try a non-standard. So just a continuous random variable x. So this time it hasn't been we haven't standardized it to make it a mean of 0 and a standard deviation of 1. So we just input what's the first number represent in the brackets. Does anyone remember? It's the mean, yep. And what's the second number? This is the variance. So we get rid of the squared, or we take the square root to give us the standard deviation. So we pretty much do the same thing as before. Menu, statistics, distributions, inverse normal. This time the area was 0.85 and it had a mean of 15.2 and a standard deviation of 1.5. So this time it's given us the x value, the continuous random variable. M is equal to 16.7549. Another example could be if it's greater than. So those were both less than, so they were the areas going that direction. This time the area is going to the right. So the probability will look, well, it's greater than 0.5, so where is it going to go from approximately? Is it going to go from the left, the right here, or the left here? The k value is more than 0.5, so it's going to be all of this area in here. So how do we find that area? If inverse normal only tells us the area going from the value left. So we're trying to find P where Z is greater than K, and this is equal to 1 because 1's all of the area, in case you forgot, minus the probability of Z less than K. So that is going to be the green area. That bit there is this little green area. Z less than K, and that's what the inverse normal tells us. Anything less than. So if we want something more than, we have to do 1 minus the little area or the other area. How did you get that? Yep, very good. 1 take 0.07 is equal to 0.93. So now we use the calculator to figure out this bit, because we know that's equal to 0.07. So we'll go to this one, 0.7, and it's 1.47579. No? So we can apply this again to real life situations like the swimmers. So if a swimmer has a size, an average, of 85, standard deviation of 10. It says it's under normal distribution, just in case you're wondering. It needs to clarify that it's normal distribution. So we're trying to figure out what is that unknown size that gives us 0.75. Again, using this, but this time it's got what was the mean? 85, and what was the standard deviation? So there you go. The size is 91, or approximately 91.7449. So yeah, that means like there's 75% chance of picking a swimmer that's up to 91.7449 kilos. So, 3/4 of the swimmers are that weight or less.